Hello friends. So our today's problem of the day is minimum swipe to group all one together second. So what is basically given in this question is we are given a binary circular array nums. We have to return the minimum number of swipe required to group all one present in the array together at any location. Okay. So what basically we are given, like, what is circular array? So circular array is defined as where we consider first element and the last element to be adjacent. Okay, so what is basically given, we are given a circular array. This is the first element, let's say first element, and this is the last element. Okay, so we are given a circular array. So what circular array where first and last element are adjacent to each other, like when we are at the last element and we will increment the index, so we will reach to the first index. Okay, so like this is the circular array, let's say. So when we are at the last index, okay, so when we will increment the value or increment our pointer, then we will move to the first element of this array. So this is the circular array. So what we are given in this question is we are given a circular array with 0 and only 1, either 0 or 1. Okay, so what we have to do is we have to find the minimum swap. Up now swap is when we swap the value from the two indexes. Okay, so like if we are swapping these two values, so this is called one swap. Okay, so what we have to find, we have to find the minimum swap to group all one together. Okay, so like we are given one at random position, so we have to group all one together at any position. Like position is not fixed, we have to group them at any one position. We have to group all one together. So like we have to find the minimum number of swap, like these, how many operations, swap operation we have to perform to group all these one together, okay, at any position. So basically this is our question. Now let's look at an example. Okay, so let's say example quickly. So basically this is our array. Okay, so if we see, so 2 1 are present at this position and 3 1 are present at this position. So if we want them to be together, either we have to swap these two 0 with these two ones. Okay, so this is the first 0 1 1 1 0. Instead of 0, what we will do, we will swap this 0 with 1 1 1 and another 0 with 1 1. So the total number of swap required are 2. Okay, now these swaps, so this will be 0, this will be 0, and this will be 0. So this is our first way of swapping. Okay, so this is in one way we can swap. Okay, or another way where we can swap is like this one we can move here. Okay, and this one we can move here. Okay, so this is another way we can do. Like there can be n number of ways through which we can do swapping. Okay, to make together all the element at a single position. Okay, so there are a number of ways, but we have to find the minimum number of swaps. Okay, minimum swaps that we required. So what basically we can do is, like, problem approach is clear to us. Okay, I think problem approach is what we are required from this question is pretty much clear to us. Okay, now to discuss a solution approach. Now what may be the potential? Okay, like first of all, to group all these one together, we should know how many ones are there, like how many ones are there. So one, so what we'll do, first of all, we will make total one. Okay, we will have a variable total one where we will count all the one present in this nums array. Okay, so here they are 5. Okay, so total number of 1 is 5. Okay, so what is the, so what we get from this, like minimum 5 elements we want together whose value will be 1. Okay, like what window we want, what size of window we want, 5. Okay, size of 5 array. Okay, we want a size of 5 window. Okay, where we will store all our ones. Okay, so in this window size of 5, we have to find like a maximum how many ones are there. Okay, so like if we consider this window size, okay, this is of 5, so how many maximum one are there? Here it is 3. If we consider this size, here we are having again 3. If we consider this 0 1 2 3 4 5, so here again we are having 3. Okay, so for each 5 size window, we have to find like maximum number of ones they contain. Okay, so once we have the maximum number of one contain in any window of size 5, then how many the remaining, like okay, we like in this case we have got like this window contain 3 elements. So let's say this is the maximum number of one which is contained in any window of size 5. So now a total number of ones are there 5. Okay, the maximum one together we have got in any window of size 5 is 3. Okay, so how many one we required or how many swap we required is 2. Okay, so the same approach we will do. We will have the total number of one in any array. Okay, then we will find out the maximum number of one present in particular size which is equals to total number of one. Okay, in this case it is 5. Okay, so we will find maximum number of ones in the window of size 5. Okay, now we have got the maximum number of one in window of 5. Okay, then what we will do, we will subtract it from the total number of ones, so we will get the minimum number of swipe that is required. Now why we are finding the maximum number of ones? Because we have to find the minimum number of swipe. So if a window contain maximum number of one, then it requires the minimum number of swipe. Okay, like in this case if it contain only 2 1, okay, remaining are 0, so it will require 3 swipe. Okay, because 3 1. Now if the maximum number of one which is contained in any window is 4, let's say in this case it is 4. Okay, and the remaining one is 0. Okay, so how many swipe we required? We know that we have the total number of ones. Okay, so we already got 4 in place. Okay, so what we can conclude it from here, like only one swipe is required. Okay, to make this, to make all one together at any particular position. Okay, so this we have got. So why we are finding out the maximum for any particular and why we are considering this size? Okay, because total number of elements, total number of one is 5. So we, from this we can conclude that only 5 element we required, only 5 blocks we required from this nums array where we have to store all these one. Okay, so I think the problem statement is pretty clear and the solution approach is also clear. Now let's discuss one thing. As we are not given the normal array, we are given a circular array where if we go from front to we will increment from front, so it will go if we increment from back, so it will go to front. Like if we increment from here our pointer, then it will go to front, it will not terminate here. Okay, so in this case, like okay, now we have let's just a second, let's clear all this. Now let's consider this. Okay, okay, so for circular array, let's consider this is our I. So we have this much in our window. Okay, so when we will move this, okay, so what we will do, if we will move this, if we move this, so this will be the this will be the next window size. So what we will do, we will remove whatever the was present at ith index, and we will add whatever is present at this index. Okay, so if in this case if it last, if it it is over here, and now we have to move it till this is the window size, and now we have to move up till next. Okay, so we have to remove this element, and we have to add another one, but our array is over. So what we will do, like if in this case whatever the I we are having. Okay, now what is the window size we want? Okay, that is 5. Okay, that we will modulo by 2. Okay, so that we will modulo by total size of an array nums. Okay, so it will work as a circular array. Okay, so it will be formed like if we consider this case. Okay, so I is 0 1 2 3 4 5. I is 5. Okay, then total number of 1 is 5, so it is 10. Okay, then we will modulo it with size, that is 9, so it will be 1. Okay, so we will add this element and we will remove this element. So what will be the next window size for us is this. Okay, so I think this is clear now. Okay, so now let's quickly jump into this code and solve this problem. Okay, so let's say int totl total ons ones is equals to 0. Okay, now let's say int current current 1 is also 0. Okay, then int let's say max ones is equals to 0. Then int size is equals to nums dot size. Okay, this is the size. So first of all, what we will do, we will calculate our window size, that is total number of 1 in this nums. So int in nums, what we will do, we will plus totl total ons ones plus is equals to num. Okay, as we know, it contain only 0 and 1. So if it is 0, then it will not be added, or it is, if it is 1, so it 1 only we have to add. So in this way we will calculate total number 1. So this has this is the window size which we have got. Now initially we have to like have some reference na, कि first window in first window size, for this initial case, how many ones we have. Okay, then we will move this window and we will eliminate the previous one and add the new one. Okay, so in this way we will have the we will find the maximum maximum number of ones in any particular window. Okay, so for that initial what we will do, we will calculate in first window size. Okay, and I is equals to 0, I is less than total on is ones, I plus plus. Okay, so now what do you do, so what we will do, we will calculate the current one, cu double r e n cu double r e n t current o n is ones plus is equals to nums of I. Okay, so what we will do now, current one we have got. So now if in this case current one we have three total 3 1, so this is currently we have maximum also, this maximum also 3 1 together. Okay, so we will keep this in max also. Max when is ones is equals to cu double r e n t current ones. Okay, now we know the maximum. For now we know the number of ones together in current one. Now we have to find for the remaining windows. Okay, so what we will do, we will loop for I is equals to 0, I is less than n, and I plus plus. Okay, now what we will do for current, now this is this is our current. Okay, let's say this is our current, so we have to move this window to the next element. So when we will move this, so we will remove whatever it was pointing previously, and we will add what it will point next. Okay, so the same thing we will do, that cu double r e n t current o n is ones is equals to cu double r e n t current o n is ones minus nums of ith we will, and then we will plus nums of. Now here we will apply our modulo operation. So what is the window size? Current is I, then what is the window size is tl total on is ones. Okay, this much we want. Okay, now if it is go, if it is go out of the index, then what we will do, we will perform a modulo operation, so it will be come back. Okay, so now, and we will store that value in max. On is ones is equals to max of max on is ones comma current on is ones. Okay, now we have got our max one. Now for any particular window, now we know that maximum one for that particular maximum one that in any particular window is 3. So now how many steps we require? So total number of one is, we will return total number total total on is ones minus max on is ones. So these many swaps are required. So now let's run this and check current ones c double r e n t variable equation. Okay, then ones max ones. Okay, now let's run this. So it is accepted. Now let's submit and check. So it is accepted successfully. So for its time and space complexity, as we are iterating from is starting to end, like linearly we are iterating, and we are using no extra variable at runtime. Okay, no extra space at runtime. So its space complexity is constant capital O of 1, and its time complexity is linear, that is capital O of n, where n is the size of this nums array. Okay, so thank you for watching.